Welcome back. We're continuing doing this worksheet. So we've done A and B now. We'll move to C. C asks us to reverse engineer all the questions from before, but this time we're going to find the distance. So the cogwheel has 50 equally spaced teeth. So we know that that means 100 positions on the cogwheel. The minimum rotational value to block light would be 2,000 radians per second. And we've got to calculate the distance that the light is from the mirror. Okay, so the light source. So this is the solution to the last one. This time we're finding this value up here, the D. Okay, T is found from using omega and the theta values over here. So let's see how we do this. So our tooth of our wheel, so our wheel here, has 100 positions. Okay, so we need to change it by a theta of 1/100th of 2 pi, in other words, pi on 50, to block the light. We know that omega is theta on t, and t is what we need to find here. We need to find the time required. We are given omega as 2,000, and we've been given theta. We're just not being given it, but we just worked it out. So time would equal theta on omega, which is pi on 50 divided by 2,000, and that will give us, that's going to be pi on the top over 50 times 2,000 on the bottom, and that's 3.14159. Yep, it's just very familiar value, by 10 to the minus 5. Okay, so that's how many seconds it takes. Now that's the number of seconds to go from the wheel, so here's our wheel, to our mirror and back. Okay, so we know that the velocity is equal to distance over time, so that distance would equal velocity times time. The velocity in this case is a known value. It is the speed of light, so that's 3 by 10 to the 8th, and the time is 3.1416 by 10 to the minus 5. So the distance that it needs to do it, so that's the time, and we need to multiply that by 3 exponent 8. I just multiplied by 3 by 10 to the 8th. I've now got to type it all in. So it's 3.1416 exponent minus 5 times 3 exponent 8. So it is 9,424.8 meters. Now, let's interpret that. That's the total distance. That's the distance out and the distance back. So we're asked to find the distance between the light source and the mirror. So it's only this distance here that I want, that L. So it's going to be half of this distance. So dividing that by 2. So the distance between light source and mirror will be 4712.4 meters. Okay. I hope you were successful at that question.